Hey everyone, it is your friend Kent Seed Odds here, and I'm joined by my friend Dave Khourshid.
Hey, how are you doing?
Good, good. Hey, so I say that you're my friend, but I now I have to ask, do you go by Dave or David?
David.
David.
There's a special type of person who's a Dave, and I'm not that type of person. I don't even know what that type of person is, but I'm mostly David.
Cool, cool. My brother's name is David, and I grew up always calling him David. But then when he got married, his in-laws and that family started calling him Dave, and now everybody in my family is calling him Dave now too, which is kind of weird. But
Yeah, I'm either David or DK,
DK, all right.
like Donkey Kong.
Oh, nice, nice.
hmm
Or Piano Man, you might. If
Actually, yeah, yeah.
Cool. Well, so David, was it like 2 years ago that you spoke at React Rally about xstate? Was that been that long?
It was 2 years ago. Yeah, I went to React Rally last year, but just to attend, which was a great time. But 2 years ago was pretty much the first time I talked about finite state machines in general at a conference, and so I was really happy to be able to do that at React Rally.
Yeah, that's that. I remember that talk because of course I was there. I never miss if I can snag a ticket, which is not easy. But yeah.
hmm
By the way, React Rally is my favorite conference. So those listening, try to get that ticket. It's so good.
Yeah,
But yeah, so I remember that talk. I was really impressed. I thought it was super cool. The like conceptually, I still have yet to actually build something with xstate, but every time I think about managing complex state, I always go back to xstate as probably the like the best solution. I need to test that theory, but that's what
hmm
I'm working with right now. So yeah, let's talk about more than just xstate. Let's talk about the general idea of what a finite state machine really is. And I'm kind of curious how you got into all of this too. So why don't we start there? I like to kind of start with the why behind the topic. So what made you interested in this, and why do you think other people should dedicate some of their brain cycles to it?
So it's going to sound weird, but it actually stems from my musical background. If you play an instrument, or anyone who plays an instrument, really, they know that there's music notation that you would read either from sheet music or maybe guitar tabs or like a lead sheet or whatever that basically tells you in a very visual way how something is going to be performed. And I realized, like, when I studied music in college, we had to study so many different genres and different types of music, but they all use the same music notation. And this music notation was expressive enough to be able to inform the player how to play these many, many different styles of music. And so, as I grew in my development career, I was thinking, what if there was some sort of music notation for logic? Like application logic, application behavior, things that change over time. And of course, naively at first, I tried to make my own, but then I discovered there's this really old computer science concept called state machines. And it was presented in a very theoretical sense, but I tried to dig deeper and think about how it could be used in user interfaces and in applications and things that weren't strictly theoretical or strictly academic. And so that's when I stumbled into state charts. And I realized that people have been asking the same questions that I've been asking for the last 30 or so years. And some people much, much smarter than me have already, developed this idea of state charts and using state machines and state charts in user interfaces and other types of applications like embedded electronics and, aircraft control, all of these advanced use cases. And then I started seeing them everywhere. And I think that that might be where, like, I've heard a lot of people, you included, just seeing these state machines in the software we write. And then we stop and think about, like, oh, this could be expressed as a finite series of states instead of just random Booleans.
Hmm.
So,
Dude, that's really interesting. There really is nothing new under the sun. But it's cool that it kind of came out of your thoughts around music notation.
Hmm.
So finite state machines, I think maybe they're like we can understand each of those terms in isolation, but together maybe we could get a more clear definition. So can you help us understand what exactly is a finite state machine?
Sure. So I could give you the Wikipedia definition, or I could just give you a little example. Let's take a promise. This is something that we work with every day as JavaScript or front end engineers, and even in the back end. A promise starts off as like once the promise is initiated, it's pending. It's waiting for a result that might or might not come over time. And then while we're waiting for that pending promise, it goes into a state of either success or failure, which is it's either resolved or rejected. And so those are finite discrete states that we could say that our promise is in. And so the main idea behind finite state machines is that you are in only one of a finite number of states at any given time. So a promise cannot be both resolved and rejected. That
Hmm.
makes absolutely no sense. It's impossible. Nor could it be pending and rejected, at the same time. And the things that cause these changes in states are events because it doesn't just happen for no reason. Everything
Hmm.
happens based on an event. And so finite state machines are these finite states, these finite number of events that either a user could do or some other external system could do, and have these states change from one state to another based on those events. And in a nutshell, that's all finite state machines are. And of course, there's an initial state. You have to start from somewhere.
Hmm. Yeah, that makes a lot of sense. So the like conceptually, we can think of many examples, like stoplights is, I think,
Mhm.
probably a pretty worldwide understood example.
Yeah.
But to like in code, this is represented by you have your object, and that object may have a certain number of properties. Like if we were to take your promise example, it would have the resolved or rejected. Like there's the response and there's the error if you're doing a fetch call or something like that. So it would be um, like there could be multiple properties in our state, but we could only have one set of those properties in our state at a time. Is that like, am I kind of going off on the rails there, or is that kind of, does that make any sense what I just said? maybe, let me take a step back. So like maybe with the um, a good thing to define is what state even is, and I define it as something. It's data or a value that changes over time. And so, like you have static data, like we have, data.json in your project or whatever. It's just static data, and that could be like the user's first name and last name. That maybe that'll never change in the lifetime of our application anyway. And that would be just data. But then there's state, which could be represented by a the position of the mouse on the page or something like that. That's something that can change over time. And so that would be state, and that's something that could be represented in a finite state machine, right?
Yeah. So you could think about state in two ways. There's the discrete finite states, and there's sort of continuous or infinite states. And so if you think about a cup of water, the water could have maybe 100 milligrams of water, or 2 cups of water, or 3 quarts of water, something like that. Like just an infinitely large number of different measurements that you could have in that cup of water. But you could also separate it into distinct categories of the cup is empty, the cup is filling, or the cup is full. And
Mm.
so finite state machines can represent the finite states of that, where you could have empty, filling, or full. And
Mm.
with extended finite state machines or state charts, which is an extension that David Harrell made in 1987, I believe,
Well,
pretty sure.
that was like the year before I was born, man.
Oh wow, yeah. uh, there's the notion of extended state, or in xstate it's called context. But this idea that we're separating finite state from this infinitely, many values of state. So, for example, your first name, your last name, my date of birth, just things that could be very, very numerous, and we can't really express all possible combinations of that.
Hmm.
And so, in the state charts view, state is a mixture of this finite state and this infinite state, if that if that makes
Yeah,
sense.
that kind of makes sense. So like
Yeah,
when I'm building a finite state machine with xstate, for example, I'm going to take my object that represents all of the states, all the finite states, and I'm going to feed that into my state machine with xstate. But then there are like dynamic pieces of data or
yeah.
information, and so that was actually a question I wanted to ask about
Hmm.
during our chat was how do you represent those kinds of pieces of information where maybe the database, like there's some sort of bad code on the back end, and so my data is in a like corrupt situation where like it is an impossible state or something like that.
Yeah.
Um, so we can't really represent that up front anyway, like as I'm writing out my state machine configuration or whatever. So like where do those two places meet when I'm like in a typical practical application that I'm building with something like xstate?
So you're talking about like if you want to represent something as finite states, but the infinite state might be corrupt or something.
Well, yeah, that may have been a little tangential. I'm mostly interested in like I do have those two different things where I know all of the states and I know what the values should be. Given my promises in the resolve state, I know what these values should be, or whatever the case may be. Um, I can represent the state of my component based off of this type of event or whatever. But
Right.
then we have the dynamic data that's coming from the server. So where
Mhm.
do those two things mesh in a like a practical real world scenario?
Okay, so this is sort of the difference between Redux and xstate is
Hmm.
that in xstate you get back this state object which it has a value which is your finite state, as in let's take a promise for example. It's either idle, loading, success, or failure, right? Those are the four possible states it could be in. And when it's in success, you have this data which of course could be anything. It's whatever payload comes from that. And failure,
Hmm.
of course, whatever error message comes from that as
Hmm.
well. And so it combines the two in this object. And well, when I talk about this, I actually keep thinking about the stopwatch example that you made
Uh-huh.
with hooks. Like you and Dan were going back and forth between this stopwatch example, and the one thing I noticed, and so this sort of speaks to the practical aspect of this, is
Hmm.
that in the stopwatch example, there was no notion of stopped or playing or reset or any of
Hmm.
these discrete events. It was just, and this is even in Dan's example when he tried to show you the right way. Uh, I mean, of course, his way is correct.
It works,
it,
but yeah.
it works, yeah. So technically correct. But it was trying to determine state and to set state based on those infinite values.
Hmm.
For example, when you pressed reset, all it said was like, oh yeah, set the current time to zero and set the play rates to zero. But those aren't finite states. But we're
Hmm.
deriving finite states from that, but it's not really explicit. And so X states, if I were to rewrite a stopwatch example in X state, not only would I have some part of the state saying, here's the current time, I would have a part of the state saying it's playing, or it's paused, or it's reset, or something like that.
Yeah, I actually I love that idea. I'm I'm totally going to rebuild the stopwatch with xstate now to figure out because I've been like thinking
Mhm.
of I need to find a good example or a good use case or scenario for
The
me
stopwatch would be a perfect example. Yeah.
yeah, and then I'll once I figure that out, I'll ask you about it, and then I'll probably do a live stream or something
Okay.
explaining how it works. That'd be pretty cool. I love that.
Yeah.
Cool. So we do have these like in the stopwatch example, you have that lapse time that can be
Mhm.
calculated from the time that the stopwatch was started minus the current time.
Right.
or the current time minus that. And so like our state machine would only represent the finite states, like it is running, it is stopped, it is. Um, Now, when it's paused, that state needs to live somewhere as well. What do you have when you're representing this finite state machine, though? Those actual values are not something that you know ahead of time. Like I don't know when the start time is going to be, and I don't know when the pause time is going to be.
Hmm.
So those wouldn't be stored in my state machine configuration object. I don't know what you call that,
Right.
but those values wouldn't be stored there. So do I separate my finite states from this more ephemeral, like these values that I'm going to find out in the future, or
So you don't
yeah.
necessarily separate them. Where they live in the state is in those two pockets. So the value, which is the finite, sorry, the finite state, and the context, which is your more
Mm,
infinite state. And so those come back in the same object. So inherently they're together. And so what you
got it.
define in your state machine is, let's say you have a start event where it tells you the current time that you started, or you have a lapse event where it says here's how long the lap was,
Hmm.
or a stop event telling you what time it stopped. Those events carry data, so they could be. And Redux does the same thing. You have a discrete type for the event, such as start, lap, reset, stop, and you also have these potentially infinite values. So start time, the person's name, something like that. And so you would represent that in the state machine as well, like assigning those values to the context or the
Hmm.
infinite state. And that actually prevents a lot of bugs that we we don't realize are present in so many of our applications. You've worked with Redux a lot, I'm sure.
Yeah, sort of.
Or-
Yeah, I worked with it a little bit a couple of years ago, long enough for me to realize that it wasn't my thing. So
Mhm.
I haven't done a lot of Redux, but I definitely understand it. So we can chat about Redux.
Right. So, and I'm sure many listeners are familiar with
Mhm.
Redux, or at least the concepts behind Redux too. And so, something I see very often is that we're basing what the next state is just on the events, not on the current state. If it is the
Mhm.
current state and they really need to use a current state, they might add an if statement, like if this
Mhm.
is this state, then do this as well. And
Mhm.
so, if you think about like a simple loading example where you're trying to load async data, and you do it based on events, where it's like I have a success event with some data, put it in there, and then change this and change that. Uh, that's not adequate, because what if I ask you, um, can this success event be done without me even loading, without me even going to the loading
Mhm.
state? And
Yeah.
the developer might say, no, that's that would never happen. And then I would go and I would tell them, can you prove it? Can you I like if we put $100 on the table, you know, can you guarantee me that that will never happen? And then they would say like, oh well, I mean the button is disabled, but yeah, it's like there's
It's
no
possible.
there's no formal way, there's no guarantee that it's impossible for that's to happen.
Mhm.
So any events can happen at any time and change data at any time, and that increases the surface area of application behavior that we really wants to narrow down and make impossible states impossible.
Oh, that makes so much sense, and that it leads into the idea that like the finite state represents not only the state that it could be in, but also
Mhm.
the states that it can travel to from that state.
Exactly. Yeah, which is a very important concept.
Yeah, that makes a lot of sense. So, and actually, that leads into a great discussion I wanted to get into as well. Is Redux is typically used for like entire application state,
Hmm.
um, and I'm curious about xstate and where it plays in with that kind of thing. Is would I be able to use xstate or some other finite state machine implementation? Am I able to use this concept for my application state? Is it typically better for a single component state? Where is the best application of this kind of thing? Like, would I use it? Here's where I use my component state, and then I have Redux for my application state. Like, where's the best practical scenario there?
So that's also one of the big differences between Redux and xstate, or just using finite state machines. And it's that Redux embodies this whole global nature. There's one single atomic state. Events can happen from anywhere. It updates the state. And then you use a bunch of fancy selectors and memoization to make sure that updating the global state doesn't make everything
Mm.
fire off and change, because that would be a performance.
Yeah,
Just
we're experiencing that with hooks because you can't exit early. Yeah.
Exactly. So xstate is sort of a different idea. Xstate really embodies the idea of local state. Now, of course, you could have like an xstate, like a state machine at the very top, and then state machines for each one of your components, and then they could send events to each other. And by having this distributed local state, you have more of what's actually known as the actor model, which is
Mm-hmm.
also it's actually an older idea than state charts. So
Mm.
the actor model, which I know this is going on a tangent, but I promise it's
Oh, no, that's
related.
fine. No,
Uh,
let's go into the actor model.
yeah, actor model is mainly used for concurrency among distributed systems, but it could also be used in user interfaces to simplify how different components work together. So, a
Mm.
real quick explanation. Let's say you're an actor, I'm an actor. The way that we're communicating with each other is the way that actors communicate with each other. We're sending events to each other. Like, I'm sending you an event with my voice, you're sending me an event back with your voice, and we change our internal state based on those events.
Mm.
Now, the way we code is sort of antithetical to that. It's more like we could read each other's minds, and we could hope that I could read your mind or something. But
Mm-hmm.
with the actor model, it's like, think of each of your components having local state, and that's it. And the way
Mm.
components change their state with relation to other components is they communicate with each other based on events.
Mm.
Now, in React, we sort of do that naturally without thinking. Like when we have on change, on whatever, on disabled, just basically all of these event handler props, that's a way of a parent's component communicating with a child component,
Mm-hmm.
or a component communicating with a parent's component.
Mm.
And so, to answer your question, it doesn't matter whether you use Redux or xstate or whatever. It's just the idea that you do need local state, and local state is not something that should be avoided. And I think that that was a thing that Redux might have unintentionally encouraged.
Yeah.
And I wrote a form library called React Redux Form, which I don't really maintain anymore. I just tell people to go to Formic, and I accept PRs and I review them and everything. But it was a form library based on Redux, and I found that people were having very significant performance issues once they had forms with maybe 50, 70, 100 fields. And this is very
Mm-hmm.
easy to envision. Like if you make some sort of spreadsheet app, or an app where you have many line items, things like that,
Mm-hmm.
you could easily get to that many inputs and that many components. And so I had to make some sort of makeshift local React Redux form for each component,
Mm.
which it worked, but it sort of felt like going against the grain with Redux.
Mm-hmm.
So that's
Hmm.
why local components data is great.
Yeah, I'm definitely a big fan of that. So what with if I recall correctly with xstate, I can like have nested state charts, right? Like so I could build like just like I have a nested component tree, I could have these nested state charts where, oh, you know what, like in React, if you need two components to communicate with each other, their siblings, you're going to lift state. What is that the
Yeah.
same concept when I'm using xstate, that I'm going to, I say I have these two places that need to communicate state, so I'm going to lift that state to this state chart above, or how does that work?
Sort of. So what you're describing would be more of having a parent state chart where two components just communicate with that parent, and that parent communicates back with the two components.
Right.
Now, nested state machines, it's more for refining states. So let's say that we have a loading or like a loading application where you want to fetch some data, but it might be fetching multiple parts of data. So you would have three states, let's say idle, loading, and success. But that loading state you might want to refine more, like load
Mm.
user, load group, load friends, load metadata, like just all these substates of that main state. And so it's just a way of refining state and grouping states in a logical way that prevents you from having to create so many different states and transitions.
Very
So
interesting.
that's what its purpose is.
Cool. Okay. Cool. So we're coming down on our time, but I did want to ask you about a couple other things, because I happen to know that you are doing some really interesting things with testing,
Hmm.
and finite state machines, that have nothing to do with whether your application is actually using xstate or finite state machines, but is actually this concept of model based testing. Can you
Hmm.
tell us a little bit about that?
Yeah. So actually, just going to your article, you wrote an article a while ago about the testing trophy. And it is an important point because it shows that unit tests, you could write 100, 1,000 unit tests, but your application could still have serious flaws, whether it's in behavior or edge cases that you might not catch in unit testing. But the problem is that with integration tests, even though integration and end to end tests are extremely important and they actually test how your application is going to behave in real life, um, these tests are difficult to author. Like just
Hmm.
authoring one takes a chunk of time, and then for every single other possible thing your user could do, you would have to author another one. And then if application functionality changes, then you have to rewrite or refactor every single one of those integration tests. And I
Hmm.
think that's one of the reasons that people tend to avoid writing too many integration tests, which of course makes your application's reliability suffer. So
Hmm.
there's this other old concept. I'm all about old concepts, but there's this old concept called model-based testing. And so what it is you would describe your application as a state machine, even in a vague way. It doesn't matter if your application is written with a state machine or not. You would just say, my application behaves like this. It starts in this state, it moves to this state, and so on. And so you describe your application as this, and then you write heuristics saying, when my application is in this loading state, there's a spinner available. And so if the spinner is on the screen, then just assume it's on the loading state. And so you would
Hmm.
write all these heuristics, and you would also write things that say the action of the action of submitting the form is physically going to the submit button and clicking it. And so with
Hmm.
the combination of this, you could take your state machine and you could trace every single path from like the start states to any other state, and you generate hundreds and maybe thousands of different test plans. And each of those test plans says, in order to get to this state, you have to go here, do this, go here, do that. So it's sort of like Google Maps.
Hmm.
Long story short, it's a way for you to automatically generate integration and end to end tests without having to write any of them by hand, which
Yeah, it's pretty
is great.
cool.
Yeah.
Yeah, I think, and the key element there is the fact that the state machine, encodes the transitions,
Mhm.
that you can go from one state to another, and that's what enables that, kind of power, right?
Right, exactly. And so you could use the same test plans, I call them, for writing both integration and end to end tests too.
Cool. Yeah, yeah, that makes a lot of sense. Where integration, maybe you mock out the back end HTTP
Mhm.
calls, but then end to end, just let them happen.
Exactly.
Um, Yeah, it's a very interesting and cool concept, and the fact that I think maybe this is a really good takeaway for people, or a call to action for people, is to say, like, take the feature that you're working on right now, and take a step back and see if you can model it in your head as a finite state machine,
Hmm.
where, okay, so the user enters my form, or they enter my, the checkout cart or whatever, maybe it's a checkout flow, and then they transition from that into the enter their payment information. And then if they enter it wrong, then they go into a state of error.
Mhm.
I feel like that exercise could really help not only in you identifying potential bugs, like, oh, I didn't think about what could happen if they hit the back button here or something,
Right. Yeah.
and then it can also have the benefit of you thinking, hey, maybe I could apply some finite state machine solution to this situation so that I avoid those kinds of bugs.
Right. And even if not, if you're just, this is something I tell everyone. It's like, if you don't need to use my library, don't use it. Take a pencil and paper, draw out each state and each arrow between the states, and you're going to quickly realize, I forgot to add that. I didn't consider this edge case and more, just by thinking of your application as a finite state machine.
Yeah, I think that's super great advice, and a good thing to kind of end on here. Um, yeah, like as you're drawing that out, I'm just picturing this in my mind, like you're drawing arrows connecting these different states, and then you realize, oh, actually, I think in my application it's right now possible to transition from this state to that one, and that should not be possible.
Hmm.
So I got to go fix that bug.
Right.
Yeah, very cool. So is there anything else that you'd like to just give to our audience to take away from this conversation? Any other calls to action or anything?
Well, if you want, please check out my xstate library. I by the time of publishing this, there might even be a new version with new features and some extra functionality around testing, analytics, simulation, and more. And I'm working on it constantly. And there's also some really great communities around it, especially on spectrum.chat/state charts. And yeah.
Cool, cool. All right, we'll get people on that Spectrum. Spectrum is fantastic, by the way. I
Hmm.
just love that. Very cool. And also, just as a teaser for people to go to xstate.js.org, because the animation is just great. I just refreshed the page to watch that animation again. So people can check that out.
Thanks. Yeah.
Um, cool, David. Thank you so much for taking the time to chat with me about this. And one last question: where
Mhm.
can people find you on the internet?
I'm on the internet everywhere at David K Piano. So piano, the
Awesome.
instrument I play, K because my last name's too hard to spell.
Cool. All right. Sounds good. That's it for this episode. Thanks everybody, and we'll be in your ears next time. Bye.
All right, thanks.